Okay, so we were debugging this last time. I don't know why Docker just came up with that. I'm in the Docker container now, as illustrated by dev container in the bottom left. So we were trying to compile the proto, and something was happening. So I'm on proto version. I'm in the dev container. Oh, maybe I didn't install proto. Do this. I think I deleted proto last time. That's where we were at. So I'm gonna copy this. Ooh. By the way, ChatGPT 5 is released now, which I don't think I'm on because I'm on the free version here. I have the paid version at home.
Oh, do you?
Yeah.
Is it worth it?
For me, for most people, probably not. Okay, so proto's right there. And we were dealing with some sort of an issue here. So just oh, that means we didn't download the full proto. That was what was happening. Proto buff downloads. Release pages. Python version. Linux. x86 should work. All right, so it's there. And that's a shared folder between the container and the base macOS. So here in our example shared folder, we have protocol. So let me just cd into the protocol, change directory. Oh, I'll just cd into that. Oh, proto dash 3. There we go. All right, so it is there. Okay, so I downloaded. I'm just going to copy this in the ChatGPT and tell it. Downloaded this and put it in the example folder. Now what? So I unzipped it too, and then I need to echo bash protobin. Okay. Oh, it unzipped it to a different words. Example, unzip. Okay, so that's unzipped. And it might be hidden. Maybe it's, I think it stored it somewhere else. I'm just gonna keep moving on. So now we need to, all right, we sourced it. So source basically means like start with that as a piece of your environment. Run this particular bash. It's common to see that in Python or Linux on occasion. Proto version is now that version. All right. Let me tell it what version I have. We get this. Perfect. Now you've got that correctly installed. All right, that seemed to work to compile the person proto file, which was basically our message file saying we want the functions for this. Okay, that's good. Now what? Now from person, import person. So that's I think that's generated code file. What if I delete that? Yeah, that's a generic code file. Let me just delete that and try that again. Try this again. All right, yeah, so see it generated this file right here. This is the compiled proto file. It's basically going to pull in protocol buffers from these libraries, and against this proto file, which is the message file, which has one message says person with a string, an ID, and an email. And then our example here is this one. So I should be able to run this now and print some stuff. Let's see here. Python 3 example.py. All right, it worked. Okay, so let me explain what's happening. I also want to mention that why I have to say Python 3 with a digit here. The Python upgrade from the major version upgrade from 2 to 3 was dramatic on the back end of Python. So dramatic that they basically needed you to run a different interpreter. And so Python 3 became the new like keyword instead of Python. So some people alias this to Python, but meaning they basically symbolically link Python 3 to Python so that they can just type Python instead of Python 3 when trying to execute a Python file. The problem is that if you have Python 2 installed, Python is also the keyword for Python. So it depends on the ordering in the symbology of the system as to which one it will execute. But most of the time, you're downloading Python 3 at this point. Very few people use Python 2 these days. All right, side tangent over. So what we did was we downloaded protocol buffers from the internet for Linux for x64. x64 is just like, hey, we have a 64-bit operating system in the processor. I can use it. I could have used 32-bit because it's backwards compatible with 32-bit. The 64-bit's the one that I chose because it's slightly more efficient because it uses more processors, has higher memory. So anyways, I pulled in, or I downloaded that. I stuck it in our shared folder in the example here, right there. I unzipped it to a particular area in the Docker container. And then I sourced it, which said, I want you to use bash with this as a dependency, and bash is the terminal. So I want you to reopen the terminal with this as a dependency. And then you run that proto compile command that we did, which was somewhere here, right there. I want you to execute. Oh, it was right here. Proto -- Python out to a person.proto file. So I want you to make a library basically for protocol buffers based on our person proto file. And it did. It's proto pb2 protocol buffers 2 version 2 Python, which is this code that it auto-generated. And you never really edit this type of auto-generated code. And then we built our example file where we imported that file, a person proto 2. Which is basically a library. We imported the library and we said, we want you to create a person object off the library. We want you to assign that person object with member variables with these assets. Alice as the name, 1, 2, 3, 4, and then an email. And then we want you to turn it into binary data. So we want you to serialize to string person. So basically serialize it to a binary string. So we have binary data. And then we want you to print the binary data, which it did, which is this, which is basically some serialization of the data. I think this is actually a memory address for where the data is. No, that's not right. It might just be the name of the object of where the data is stored. And then we want you to deserialize that information back. So we take person, we want to parse from string. So we know that there's a string data in a binary format. So we want you to parse it back to like just regular like format in Python. And then we want you to print the deserialized name is just it's just this word right here. We want you to print that word. And we want you to print the object name, object ID, and object email. Does that make sense?
Yeah, quick question, Ron. So
Yep.
when you do that parse from string, you said that you know that that's string format, binary data.
Yep.
What if you have like, for example, UCI has like strings as well. They have doubles. They have all different types of data.
Mm-hmm.
How would you parse like when it's like not just a string, when it's multi type, or am I missing the point?
So yeah, no, you're spot on. You have to know the data type that you're taking. You have to know
Mhm.
basically a specification of what's coming in. And so usually in UCI, it's like an object that you've created or a UCI object.
Sure, it'd be
And
like a
Yeah,
type. Yeah.
exactly. And that type has particular fields. And so you know ahead of time the fields that you can pull from for that type.
So if your person up there is the type,
Mhm.
you have different fields too. You have like a string field, looks like there's an int there,
Yep.
and then there's a string.
Yep.
So that's kind of similar to what UCI would be. But so you could probably do the same thing you're doing with UCI right now. It's still
Yep.
a string, right?
Correct. Now let's talk a little bit about UCI. So yes, 100%. Protocol buffers are basically like UCI. UCI is actually just the message set specification. So it's just these attribute field specifications with like the types. But OMS itself is a particular way of serializing and sending the UCI types as XML data files. And so when you hear critical abstraction layer or abstract service bus, basically everybody has built their own version of a middleware that you have to serialize in a particular way to send data over that middleware called the critical abstraction layer.
Yeah.
And so you send UCI types over that critical abstraction layer. Now, each critical abstraction layer is kind of built with its own flavoring, but it's some sort of TCP IP protocol sending information. And I'm not sure you can, this is starting to get to the edge of my UCI knowledge because I haven't worked with it for a while, but I'm not sure you can actually use protocol buffers with UCI as a serialization method.
So we are doing that on Cosico and Air now, which is why I wanted to work through this. So talking to Rob, and I want to run this by you. So like the cal is pretty much what you have there on the bottom. It's the parse from string. It's the unpackaging of whatever comes, like they have all the hooks in to know what data fields they need to go and unpackage. And so those two things have to match. It's my understanding of it, but I don't know if you can make it better.
So there is a step here that I'm going to kind of demonstrate with something else here as we continue these lessons, but you have sort of a few functions. You create and fill out the fields of the message. You serialize it to binary. So you turn that like basic text into binary in memory, like really compressed binary.
Yeah.
You send it over a middleware. So you basically call these sender and receiver functions.
When you say middleware, is that the cal?
Yeah.
Okay. So you could, like, if you're over the air, you could compress it and send it over like a link 16, like an IP or an IP to a middleware right before that. Okay.
Yep. So you call basically a sender and receiver and you broadcast it out to a specific message topic.
Got it.
Which we haven't gotten to yet, but that's basically like a topic is a message type that you as the receiver on the other end subscribe to if you want to get. So that whole observer pattern we were talking about, like I'm going to subscribe to the topic that gets me all the air data. And then this person says, I'm going to publish this message to that topic. So all the people who are subscribed to that topic get it. You're not sending direct to services, you're sending and subscribing to topics.
Sure. Well, like different configurations have different services that would subscribe to different topics, right?
Correct.
Like if you're just like the flight lead, you're the tasker, you're not going to subscribe to like all the sensor tasking topics. You're just going to subscribe to like the task topic, so then you can send it to the other peers that are configured to do other things.
Spot on.
Okay.
Deserialize back into an object. So from here, you take that, you deserialize back into an object. So one thing I was going to say with the cal is I believe that the cal not only contains the middleware, but it also contains the serialization functions. Usually. Now it sounds like you can use protocol buffers, and probably a lot of cals are subscribing to protocol buffers. But at some point, I believe at a minimum, it has a sender receiver, but I think some of the cals come with the serialization capability. If they don't, then it does come with sender and receivers, and the sender and receivers send and receive binary data specifically. So we're getting out of my knowledge here. Rob will know which one is which, whether these serialization functions are contained in the cal or not. but the senders and receivers are, and the ability to stand up the middleware and configure the middleware, basically.
Okay.
Yeah.
When you say stand up and configure middleware, what do you mean?
So middlewares are like ZeroMQ, ActiveMQ, DDS, OpenDDS. Like there's a bunch of different ones, and they all basically have like IP capabilities of sending like IP messages back and forth to other services, and you have to configure which topics are available on the CAL. And so these like basically these providers of CALs have the OMS topics that are allowed, and they have implemented those, and they come with configuration files so that you can configure the CAL to say, I want you to always use like TCP, and I want you to have all these valid topics, and then they'll claim like our CAL is faster, so they might do some modifications to like ZeroMQ under the hood to make it move faster. Some of them might have shared memory where they're actually passing a memory address rather than a IP serialized data. I don't think too many do that, if any. But there's whole kind of organizations within the primes to build CALs. But honestly, the one that everyone uses in the Air Force for operational reasons is the 76 CAL, maintained by the 76 software group, which is not a gut contractor CAL. It's a government-owned CAL. So in terms of CALs, you have the reference CAL, which you get from basically if you download OMS from like VDL, it comes with a reference CAL. It's not a super efficient CAL, but it is a CAL. And then you have the 76 CAL, which is like apparently the deployed CAL that most people use in the Air Force. And then and then like there's like an NG CAL, there's like an LM CAL, like everybody's got their own CAL.
Got it.
Which is the middleware, the sender receivers, and the implementation of the topics, along with configuration files. CALs that work decentralized also probably have to have some extra configuration under the hood, where it's like, I'm going to send a message and receive messages between CALs that are on different hardware. And so the actual data link portion of that is handled not in a service, but within the CAL. There's probably vendors that do that. But in my experience, most people have services that handle the data links rather than CALs. So there's a lot of flexibility you can do. Does that make sense?
Yeah, that makes sense. That's massively helpful.
Yep. Awesome. So we made it through our first protocol buff example. Go ahead, Justin.
Oh, never mind. I was just saying I'm on a hunt to become a menace in UCI.
Nice.
It's coming up a lot with both COSECO and Air. So
nice. Okay, so now maybe I'll go back to this example, and I'm going to say, I'm going to cut this out. So this, I want to send the message over a loopback IP using sockets. Give me code to do this. All right, I'll explain what's happening here. There's a loopback interface, arbitrary non-privileged port with socket print. All right, so I have to set up a server. So I got to set up this file called server.py. Spell it correctly. All right. Let me talk about this file real quick. So this file is setting up a server. And the server is basically like an IP address that you can send data to. A service on an IP address that you can send data to. Servers or sockets in Python, a socket is basically opening up a port. Remember when I talked about ports on the kernel? At an IP address. And so it allows a computer to talk to another computer. This example right here, host 127.127.0.0.1, is what's called a loopback interface in your computer. Most computers have a loopback interface that is this address. And what loopback means is that if I send a message to that address, it then pretends like it's coming from that address. So it kind of loops back to itself, and you send it, and then you receive it from that address. So you can both like send to, and you can send and listen to that address with two different functions. And so if you send something to that address, your other address will listen to that address and receive it. Whereas if I was trying to do it with some other IP out on the internet, it's not like loopback internal to the computer. I would have to go out and then come back. Whereas this is like internal to the computer. I'm probably not explaining that super well. It probably limits my understanding of it, but basically it just loops the message back to you in the computer. It's a free IP address to use, basically. And then this port is, as it says, an arbitrary non-privileged port. I didn't explain this before, but certain ports in the computer, like there's a bunch of ports in the computer. Obviously, this is port 65,000 something. The ports in the computers are actually like pre-assigned for the most part to specific things. Like port 443 is like a VPN port. Port 80 is an HTTPS port or an HTTP port. 8080 is an HTTPS port, I believe. And what that means is that like it only accepts IP packets that meet the form factor of like what that port is expecting to send and receive to specific addresses. So most ports on the computer are reserved for specific functions. Some of them are not. For example, 65,432 is non-privileged, meaning it's not like pre-assigned to a particular purpose. It's just a generic port. So we can use it essentially to open a socket. To create a TCP, this is a TCP socket. We have this cool little library called socket. So we use socket, and then we use a static function within that library, basically called socket. We don't have to create an object off of it. We can use it directly. And basically, this is really fancy syntax. This is creating an object. It's basically like, this is a constructor in a class. So it's like basically create an object as S. So create a socket as S. Fancy Python syntax to basically combine a function and create an object at the same time. And then you have the address, which is socket dot AFINET. Honestly, I'll be honest, I don't know what that attribute means. And then socket.sockstream, but those are basically predefined members of the socket class that have specific, basically text or numbers associated with them that configure the socket in the constructor. Does that make sense? That is maybe really confusing, but it comes with basically configurations. So there's probably other ones like blah, 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 that configure the socket differently. But this is kind of pretty standard socket configuration. So I'm basically creating an object, and I'm going to name that object S. Now what am I going to do? That socket object, I'm going to bind that object to this address and this port, meaning I'm going to make it use this address and this port. Mm-hmm. And then I'm going to say, I want that socket to listen on that port for whatever it hears. And this print just says, hey, let me know when it's listening.
Listen is a class function of the socket.
Class function of the socket, and it basically says like wait for a message. Mm-hmm. And if you hear a message, like then do something.
Cool.
Connection and address. So socket.accept basically says like once you I should probably tell ChatGPT to print this with comments better rather than me explaining it. Basically says accept the connection and then give me the connection and address. And then with the connection, I want you to print the address and then data.equals connection.receive. Then I want you to receive the address with a buffer size, receive on this connection with a buffer size of 124. I think this is bits. Maybe it's bytes. It's either bits or bytes, or 1024 bytes. And then I want you, if that data comes through, I want you to, assign, because I know what I'm sending to it. I want you to take the person object, assign it here, or binary object. I want you to parse the binary object, then I want you to print the information. That was like super long-winded to describe what is happening here, but I think I could probably run this and it'll probably work. Server is listening. Oh, I need to send the data. So this is just the listening server side. We're out of time, but next time when we start this,
this is so helpful, Ron.
I froze the computer. Yeah, good. The client side. So these clients and servers, I think I mentioned that when we were going through foundational lessons. Servers just like, kind of produce the data. Clients receive the data. And so basically it's just, the syntax, it's two computers. There's a server and then there's a client. So this is the server.
You said that the server receives the data, the client produces it.
The server, they both send and receive. The server semantically means like, it's like the far away thing, and the client is like the user.
Sure.
That's what it semantically means. In reality, they're both computers that are sending and receiving data. So
okay.
You'll hear it kind of abused. But you can think of a server as like the far away computer on like AWS that you're using, and the client being like your local machine.
Got it.